What's up, everybody? How you doing? We are going to, well, first off, happy Monday. We are going to start this week with doing three-dimensional shapes. So a lot of what we're going to be doing is going to be like conceptual, and I'm going to like really try to figure out some ways to help you guys like get through this, especially because like the things that I would do in the classroom, I can't necessarily do because we are not in the same place. But bear with me. If you're watching this video, that means that you had an entire page of notes that you should have been like reviewing, copying down, writing them down in your notebook. But just in case some of that was like a little bit confusing, I'm going to explain a couple of important things. So the first thing I want to kind of highlight is the difference between prisms and pyramids. Anybody that was in my math class for 6th grade understands that like the big difference between a prism and a pyramid is that a prism has rectangular faces and a pyramid has triangular faces. And so like that's the major difference. A pyramid has triangle faces, a prism has rectangle faces, and a prism has two bases while a pyramid just has one. And then another thing that I wanted to review really quickly is just, so here's the visual example of what it means to have a prism or a pyramid. As you can see, the prisms have rectangular faces here all around, where a pyramid has a triangle face, and the shape that's on the bottom could be a square or a hexagon or another triangle or a pentagon, but the faces that go around are all triangular. The other thing is that we classify the names of prisms and pyramids. The first name is given to the shape from its base. So the base of this rectangular prism, the first name is rectangular because the bases, this shape at the bottom and this shape at the top, is a rectangle. Triangular prism, there are two triangles, one at the bottom, one at the top. Those are the bases. The base for a pyramid, a triangular pyramid, means that there is a triangle as its base. There's a triangle at the bottom. Here, there's a square at the bottom. This would also be called a rectangular pyramid because squares are just a special kind of rectangle where it's even on all sides. This is a hexagonal pyramid because it has a hexagon as its base, a hexagonal prism because it has a hexagon as its base. But the difference between a hexagonal prism and a hexagonal pyramid is that the prism has rectangular faces all around. The hexagon pyramid has triangle faces all around. Same for the pentagonal prism and the pentagonal pyramid. The major differences in the faces. So the first name is just given to it from its base, and then the last name is given to it from its faces. That's going to be super important as we kind of go through. The vocabulary that you guys are used to are two-dimensional shapes. These are figures that have two dimensions, length and width. They do not have a thickness or a depth or like a height per se. They just have two dimensions. How far horizontal does it go? How far vertical does it go? 3 dimensions is when you add a different direction or a different dimension of direction. So that's when you start thinking about height or depth. So you're thinking about length, width, and height, or length, width, and depth. We know what plane is. A plane is a flat surface. All two-dimensional figures have a plane. Parallel means that lines are the same distance apart on every point of both lines. They are the same distance apart and they never intersect. Perpendicular is a line that forms a right angle with another line. The new vocabulary that we need to be familiar with is cross-section, and that is the two-dimensional face you get when you're slicing through a three-dimensional object. Cross-sections for us are going to be, it could be a number of things. It could be, so when we're thinking about cross-sections, here's an example. If we were to slice the earth in half, we would have a circle as its cross-section, but we would also be able to like see the layers. If we were to slice this, what is this, a cantaloupe? If we were to slice that in half, we would get a circle as its cross-section, as well as like we slice this brain in half because we want to like look at what's inside the brain. They would slice it in half, and this is the shape of the cross-section. I'm really hungry, so I'm thinking that one more real world example is like a slice of, I like a loaf of bread. Every slice of bread is like an example of a cross section. The bread is, for all intents and purposes, a rectangular prism. And if you were to like create a cross section, meaning you just like sliced that rectangular prism, you would get a rectangular or like a square cut kind of cross section. So make sure you watch that. And if you definitely need some more help understanding that video, you should definitely go back and watch that video. I'm going to pause right here so that you guys can make sure that you have like some of the strongest notes possible. I do not want you to like just breeze through this work. You're going to be coming back to this work in 8th grade, high school, and it's important that you're taking the good notes. Last week, I saw a lot of you guys have very low points, and all I can guess is that you were not actually trying. That's not going to get it for math. Like, you just trying to breeze through and get it done to say you got the points. Yeah, it's not going to hurt your grade. I know that, you know that. But are you going to be ready for 8th grade when this is ready? Pause the video. Make sure you're taking really good notes. This lesson is going to be tough if you're just thinking that you can breeze through it, and you're going to get really low points if you think you can. All right. So for our first example, we have a shape right here. This imaginary white piece of this white plane is cutting through the middle of this solid 3D figure and creating a cross section. If we're looking at the bottom, we can see that the cross section here looks like a square. I mean, we can see that the base looks like a square. And so the cross section also looks like a square. There are 4 sides to our base. So our cross section has 4 sides. The bases look like squares, so the cross section is going to look like a square. The other thing that I'm noticing is that this plane that cuts through this prism is cutting parallel to the bases. So let's just look at these, like some questions to kind of deepen our understanding. What is the name of the 3-dimensional figure being sliced? I see that the base is a square on the top and on the bottom. And I know that a square is a special type of rectangle. So I'm going to start off and say that the first name is rectangular. And then the faces are rectangles. And I know that when a face is a rectangle on a prism, that's a prism and not a pyramid. So this is a rectangular prism. Rectangular for the bases, prism for the rectangular faces. Is the figure above being sliced parallel to its base or perpendicular? It's being sliced parallel to the base. And I can tell because the plane and the base do not intersect, and the cross section is the same shape as the base. And this is basically the type of quality answer that you're going to put when you're noticing. What you're going to notice with these shapes is that when you are cutting parallel to the base, your cross section is going to have the same shape of the base. When you are cutting when you're cutting perpendicular to the base, then your cross section is going to have the same shape as the faces of that 3D solid object. I'll show you what that means in a little bit. What is the shape of the cross section that's being formed? Again, remember I said that a square is a special type of rectangle. In geometry, you only call a square when it's like when you're talking about the base of a cube, because a cube is a 6-sided shape that has squares on all sides. Other than that, we'll just like default call this a rectangle. All right. So this is an example of figure 1 is when we cut it. Figure 1 shows when we cut it parallel to the base. And figure 2 shows when we cut it perpendicular to the base, which means that like we're cutting into the base now, whereas as before we would never intersect with the base based on this cross section. In figure 2, how is the shape being sliced perpendicular to its base? What is the cross section that's being formed? This is definitely a rectangle. Even still, for the purpose of this question, I'm going to say that the first shape that's being cut is a square, so that you can like see the difference that the figure 2 is cutting a rectangle. Let's look at example 3. Example 3 shows me the cross section of a triangle. Above is a section that was made when a 3-dimensional object was sliced parallel to its base. What was the original three-dimensional figure before it was sliced? If I slice this cube any which direction, I'm not going to get a triangle cross section, and not the same for a rectangular prism. Because what I know is that when I cut an object parallel to its base, it's going to take the same shape as its base. So I'm looking for a shape that has a triangular base. The only thing that has a triangular base here is the triangular prism. A square pyramid does not have a triangle base. It has triangle faces. So if we're cutting parallel to the base on this triangular prism, the bases being this triangle here and this triangle here with the rectangular faces, then we're going to get a cross section that looks like the base because we're cutting parallel to the base. Key point alert, I've said it, but now you get to read it. When you slice a three-dimensional figure parallel to its base, the cross section will always take the shape of the base. All right? Really apply yourselves. Do not just go through this stuff guessing because it's going to bite you in the butt. Even if you get the questions wrong, I have some really helpful tips when you like finally hit submit. Make sure that you actually hit submit on this thing when you're done. Looking forward to seeing your responses and seeing the hard work that you guys put in. Proud of you. Love you every day. All right. Peace.